Welcome back. In this video, we're talking through the material in section 1.4 of your textbook. And in 1.4, we're going to briefly remind you about simple random sampling. And we're also going to talk about other sampling methods like systemic sampling, stratified sampling, cluster sampling, and multi-stage sampling. So make sure you know the difference between each of these sampling methods because that's going to be important for your test and for the rest of the semester. Now, simple random sampling, again, the idea is that you select individuals from a population based on the results of a random number generator. And this is effective, especially if you have a large enough sample size. It's effective at, whenever you use a simple random sample, there's a very small probability that any kind of bias is going to creep in and ruin your results. However, it does require what we call a frame, and a frame is just a list of all of the individuals within a population, right? It's an indexed list, so that when your random number generator generates a number, you actually have an individual from your population that that number corresponds to. So as an example, let's say the city of Midland is seeking input from residents about whether they want to spend the city's budget on improving roads or building parks. We might ask, is this a survey or experiment? This is a survey. We might ask, is it qualitative or quantitative? And actually our responses represent a qualitative variable because remember, qualitative means the same thing as categorical. And we're sorting each of the individuals in our sample group into one of two categories. We're sorting them into a respondent that wants to improve roads or a respondent that wants to build parks. So this is qualitative. The population is going to be Midland residents. The sample is going to be, whoever they pick, right? So we didn't really discuss this, but maybe they're going to pick like 1,000 out of the Midland residents that are asked to complete the survey and respond, right? So it's going to be a subset of the Midland residents. And, hopefully they're going to pick a good sampling method to choose those 1,000. Now, the parameter, the characteristic of the population that we're trying to figure out is probably, the fraction that want roads, right? Or the fraction that would prefer spending money on roads to building parks. And, obviously, if it's just a binary choice like this, you could say what the parameter we're interested in is the fraction of the population that's more interested in building parks than improving roads. But in either case, like the fraction that want to improve roads is just going to be 1 minus the fraction that want to build parks, right? So if you know one, you know the other. Now, the statistic, remember a statistic is just an estimate of a parameter. So this would actually be the fraction of the sample that prefers roads, for example, or prefers parks, either way. Whereas the parameter would be the fraction of the whole city's population that prefers roads. And so you can see the difference here. We're going to use a statistic to estimate the parameter. We're going to use the fraction of our sample that say they prefer roads to estimate the fraction of the whole city's population that say they prefer roads. And then the frame would be a list of all of the residents of Midland, right? In order to use a random number generator to select your 1,000 Midland residents that you want to be part of your sample, you actually first need a list of all of your residents so that you can assign them an index and you can pick them using the random number generator. So the downsides to simple random sampling is you do need a fairly large sample if you want accurate results, right? So probably, in a city the size of ours, 100 or I should say 1,000 or 1,000 residents is probably a large enough sample. And it does require a frame. And I put dollar signs next to this because a lot of times it costs money to generate a frame. Not always. Like if you were talking about a population of students at Midland College, Midland College probably already has a list of all the current students in a database somewhere, and so that frame is easy to access. However, let's say you're running a business. So like if you are operating a ice cream shop and you want a frame of all of your customers, that would actually take some time or money, right, to figure out who your customers are. Some customer comes in and pays with cash and leaves. You don't know their name, you don't know their address, you don't know how to find them to deliver a survey. And it actually can create, a little bit of pain or cost a little bit of money to hire somebody to create a good frame of who your customers are. And so, a frame could be really inconvenient depending on the survey. So, another type of sampling you could use for a good survey is called systemic sampling. And these are the steps for doing a systemic sampling survey. You're going to guess the population size. Number 2, you're going to figure out your desired sample size. So your sample size obviously is going to be less than the size of the population, right? Maybe like 10% of the population. If it's a really, really large population, maybe that's just 1% of the population or 0.01% if you're talking about the whole country. We're going to calculate a number k. So you let lowercase k be capital N divided by lowercase n. So this is the ratio of the population size to the desired sample size. We are going to generate just one random number. I'm calling it lowercase p, but p is going to be a random number between 1 and k. And then starting with the pth individual, so let's say the random number we come up with is 7, right? So starting with the 7th individual, we're going to choose every kth individual for the sample. So actually, let's just give some numbers to this to start out with. Like let's say my population size is 1,000, my sample size is going to be 100. That means that k is equal to 10. And so we're going to start with the 7th individual, and then after the 7th individual is surveyed, we're going to choose every 10th individual for the sample. Okay, so take a moment with that if that doesn't make sense, and we'll give an example here too. So HEB is a grocery store around here, and let's suppose the HEB corporate office wants to determine the level of customer satisfaction at the Midland HEB. And so let's say we give the HEB customers a survey, and we ask the customers, are you very satisfied, satisfied, not satisfied, or very unsatisfied, right? Well, survey or experiment. This is a survey. Remember, an experiment is where we actually purposefully try to influence the results. We have like a control group and an experimental group, and we apply some treatment to the experimental group. This is just a survey. The level of measurement here is going to be ordinal. So you might reference a previous lesson for the levels of measurement. But we have customers basically sorting themselves into 4 different categories. And not only are there different categories, but they have a particular order to them, right? Where we think it best if the customer is very satisfied, and it would be worse if the customer were unsatisfied. So these categories have an order to them, so we say it's an ordinal level of measurement. The population is going to be the, basically the customers of HEB in Midland. The sample is not going to be all customers, but it's just going to be some of the customers, right? It's not going to usually be possible to survey all of your customers. The parameter that we're trying to figure out is kind of just, the distribution of satisfaction categories for all customers, right? For the whole population. The statistic, remember a statistic is just an estimation of a parameter. Our statistic that we're going to find at the end of the survey is the distribution of the satisfaction of just some customers, the ones that belong to our sample. The frame, if there would be one, would be a list of all of the customers of HEB. But if you think about that, it's not really possible to figure out exactly who all of your customers at HEB are, Because like I said, some people pay with cash. You have no idea who they are. They just, come and shop there, but it's impossible to be able to track them down, really. So we're not going to be able to make a frame in this case. So again, this is just a recap of the steps for performing a systemic sample. If you worked for HEB and you wanted to perform the survey, you would need to guess the population size, so guess how many customers you have in this area. You would want to figure out your desired sample size, so you have to choose a sample size. You would have to calculate that lowercase k. You'd have to find a random number p between 1 and k. And this might be what it looks like. Let's say they guess the population size, and they guess that they have 10,200 customers in this area. And let's say they'd say, well, our desired sample size is going to be 500 customers. Like, we're going to have a good enough survey data if we can snag 500 customers and get responses. So we let lowercase k be capital N over lowercase n, so that's 10,200 over 500, which gives you 20.4, and we can round down that k, so we can round it down to 20. We let p be a random number between 1 and 20, so just randomly we say p is 17. That means starting with the 17th individual, we're going to choose every 20th individual for the sample. So imagine you are working for HEB, and HEB has an exit, and customers are leaving the store, and you are there watching customers leave, hanging out, and you've got your little clipboard with your survey on it. What you're going to do is you're going to count customers as they leave. So you show up Monday morning bright and early. You're going to count 16 individuals and just let them leave, without accosting them and trying to get them to answer your survey. And then the 17th individual, you see him or her leaving the store, you're going to stop them and ask them your satisfaction questionnaire. Then you let them go, and then after that, you're going to wait and choose every 20th individual, which means you let 19 of them go, and then you stop the 20th one, and you let 19 go, and you stop the 20th one, like this. So you're going to basically survey the 17th individual, and also the 37th individual, and also the 57th individual, and also the 77th individual, and basically every 20th individual. That's who you're going to ask the survey to. Systemic sampling, if you can't tell, is a way to choose customers in a way that's basically random, and eliminates bias through that randomness. But you'll also notice this does not require a frame. We don't actually have to know who our customers are to perform this systemic sample. And so that's the benefit above a simple random sampling, is that this does not require a frame. Okay, so how could convenience affect this data? And this is just kind of, open for you to think about and brainstorm. Maybe one way convenience could affect this data is maybe the person interviewing, interviewer, the person asking the survey to your customers walking out of the store, maybe they have to eat lunch. And so maybe while they're eating lunch every day between like noon and 1, there's a whole group of shoppers that like to do their grocery shopping between noon and 1. And so that group of shoppers never gets their opinion. There's never a representative sample of that group of shoppers during the lunch break or something like this. So I don't know. This is, again, up for you to think about. The downside to systemic sampling is you still need a relatively large sample size. It doesn't have to be huge. You can think to yourself what would be reasonable for a given population size. But the upside here, again, that I want to emphasize is it does not require a frame. Okay, new type, stratified sampling. The idea behind stratified sampling, and you really have to pay attention, it's not super obvious what we mean by stratified sampling, but we are going to partition the population into multiple non-overlapping strata. Think of strata as like a group or a set of individuals. But we're going to partition the population into multiple sets or strata in which individuals might give a similar response. So you already have some hunch that different groups of individuals would respond in a similar way. And so that's how you're going to stratify or partition your population. Within each stratum, we're going to use either a simple random sample or a systemic sample, right? So maybe most commonly we're going to use a simple random sample. But if we can't make a frame, remember a systemic sample is good for those situations where you cannot make a frame or it's too difficult. And then lastly, we choose a sample size from the stratum proportional to the stratum size, right? So if you've got one large stratum and one small stratum, you're going to sample maybe 10% of the large stratum and also 10% of the small stratum. So your sample is going to be proportional to the stratum size. So this is the stratum. Stratum is just singular for strata. And then this would be the sample. I notice small stratum, small sample, and large stratum, larger sample. Just proportional to the stratum size. Let's see if I have an example. Yeah. So suppose you are a state representative. So you get into politics and you're trying to represent your constituents. And you're asked to vote on a bill that would provide better funding for schools, but it's also going to raise the sales tax from 8.25% up to 9%. And so obviously there's pros and cons here. Some of your constituents are going to care more about schools. Other constituents will care more about lower taxes. And you want, basically, like a good representative, you want to represent your constituents. And so maybe you try to get input from your constituents by conducting a survey. What would be some ways to partition the constituents into strata? Remember, strata should be groups of the constituents, should be subsets of your population, where you expect them to actually respond to the survey in a similar way, right? So this population of constituents, maybe I can break them down into parents with school-aged children and maybe adults without children, right? Because you would think that the parents with school-aged children would be more likely to vote in a similar way, right? Parents with children would respond, probably, let's provide better funding for schools. And if you have adults with, no child, maybe they would say, well, I actually care more about keeping the tax rate low. And so this would be a good way to stratify. Another way to stratify might be by income, right? So people with a really large income, maybe they think to themselves, oh, well, I can afford the additional sales tax. And so they're more likely to vote for increased funding for schools. Whereas if you have middle income respondents or, lower income respondents, maybe they're more likely to say, well, I can't afford the tax hike. And so I'm more likely to just say, well, keep school funding the same. So that would be a way to stratify or partition your population into non-overlapping groups that might respond the same. You might also partition your population into political party, right? Like if you have a group that identifies as independent, and you have a group that identifies as, conservative, and you have a group that identifies as progressive, then that would be another way that you could stratify your population, right? So you're just dividing your population into non-overlapping subgroups that you think might respond the same to your survey. The upside of stratified sampling is it actually does reduce the sample size required to get a good statistic. Remember, a statistic is an estimate of the parameter that you're trying to study. And what that means, the way that works basically, is that with simple random sampling, you are kind of relying on the randomness of the random number generator to select people that belong to all partitions, right, that belong to all of the strata. But if you actually intentionally stratify your population, and then inside each stratum, you apply some kind of simple random sample, you've actually already guaranteed that you've accounted for that sort of bias that's built into each stratum. So you already know that those groups are adequately represented without having to rely on the randomness, and hence we say it reduces the sample size required to get a good statistic. The downside is it will most likely require a frame, because the frame would need to tell you who belongs in which stratum, right? So you don't know really how to partition your population if you don't have a good frame most of the time. Cluster sampling. So this cluster sampling might sound a little bit like stratified sampling, but it's not. So I just want to really emphasize this, that it is not the same thing as stratified. And students sometimes have a hard time keeping these apart in their head, but I just really want you to know the difference. And the biggest difference between stratified and clustered sampling. Remember, stratified sampling is actually more difficult. It requires more effort on the part of the researcher, but it actually provides a better statistic, a better estimate of your parameter. Cluster sampling is actually a little bit convenient. It's not more work, it's actually less work on the researchers to perform a cluster sample. And it actually does decrease, the efficiency of your statistic, right? So again, we talked about how convenience is never necessarily a good thing for the results. But basically, we might want to use cluster sampling when we want to save some money. So cluster sampling is a money-saving shortcut, basically. And the idea behind cluster sampling is we're going to partition the population into multiple non-overlapping clusters, and you're like, hey, that sounds like stratified, right? I mean, that sounds familiar. That we're dividing up the population into multiple non-overlapping clusters. Sort of sounds like strata, but again, not. In which the distribution of individuals represents the population. Ooh, that is different. That's actually really important to pay attention to. This is what's different from stratified difference. So in stratified sampling, we actually want each stratum to vote or respond the same, and between the strata, we want the strata to respond differently. With cluster sampling, we want actually each cluster to represent the distribution of the whole population. And so from one cluster to another, we actually want the same distribution of responses. Then what we're going to do is we're going to randomly select which clusters to include in the study, which means not all clusters will be included. This is another difference from stratified sampling, because in stratified sampling, you have to include all of your strata. But with cluster sampling, not all clusters are going to be included. This is how we save money again, right? So I said this is money saving. We save the money by not including all the clusters, right? If you go to fewer places to ask your survey, then that's less time you have to pay interviewers, and so on. Now within each cluster, we're going to use either a simple random sample or a systemic sample. Again, sounds familiar. And then we're going to choose a sample size from the cluster proportional to the cluster size. And again, that should sound familiar. So if you have a small cluster, then you've got a small sample. And if you've got a really large cluster, then you're going to have a slightly larger sample. Excuse me, jumped ahead. So here's an example of cluster sampling. So suppose that you are a U.S. Senator. So I have another political example. And you're asked to vote on whether to raise the income tax rate to provide more funding for the military. So you want, again, the input of your constituents, so maybe you conduct a survey. What are some ways that you could partition the constituents into clusters, and what are some issues with that, right? And so if you're trying to save money and you're trying to, run your office of U.S. Senator on the smallest budget possible, you don't want to pay for a bunch of employees to go out and survey your constituents. Maybe you could partition your constituents into clusters that are like cities, right? So as a U.S. Senator, you have a territory that probably includes many cities. And it would save money if you didn't have to send one of your staffers to drive around in a car between all of those cities. Maybe if they only visited a subset of those cities, you could save money on both like gas and time. And so you're going to basically ignore some cities and only sample from a subset of all of the cities in your region. And so obviously the issue with that is that you lose some opinions from some cities. Okay, so let's suppose you're trying to collect demographic data from the city of Chicago. It's a big city, and let's say you have a really tiny budget. So you don't have a bunch of staffers. It's basically you just going door to door, asking people about their household income and things like this. You might partition the population of your city into clusters, maybe by city block, right? So you have a city, and you could just say, well, each block is a cluster, and I'm going to sample from that block and just choosing randomly that block and that block and that block. And by only choosing individuals for your survey from these 5 blocks, it saves you a whole lot of time and money, and you don't have to walk as far. You don't have to pay as much for parking or whatever you're doing to collect this survey data. Now, this is more convenient for you, and it saves money, but also just recognize that this is slightly less efficient for creating a good statistic than if you had surveyed individuals from every city block. So the upside is it's more convenient. The downside is that the convenient might affect data quality if you don't manage that properly. Basically, what I mean by manage properly is we want each cluster to be roughly or approximately the same distribution of responses as the population as a whole, right? So you hope that each cluster has some people that are higher income, some people that are lower income. You hope each cluster has some people who are highly educated, some people that are less educated, and so on. Some people that are conservative, some people that are progressive, and so on. Okay. The last thing we'll talk about in this section is multi-stage sampling. And so obviously it is what it sounds like. You have multiple stages. So in multi-stage, you might have clusters inside of strata, or you might have strata inside of clusters. And let's just jump into the example so you see what I mean. But it's kind of like sampling strategy inception, where you have basically a stratum belonging to a set of strata, and inside the stratum you have clusters, right? Or vice versa. Maybe you have a big cluster, and inside that cluster you have strata. So you want to find out what proportion of Americans are in favor of legalizing marijuana, but you don't have a large budget, right? So you want to save money, and you want to get a good representative sample of the population of all Americans without having to spend a whole lot of money carrying out your survey. So what you should do is you should partition the U.S. into strata based on region. So your strata, remember those are non-overlapping sets that you expect might respond similarly. And so you might make those strata the Southwest, the Southeast, the Midwest, the East Coast, the West Coast. So geographic regions. Within each stratum, you should partition into clusters, right? So cities and towns within a particular geographic region, maybe they represent the same kind of distribution that you would get from the entire stratum by itself. Then you're going to randomly select which clusters to visit in each stratum. So we basically ignore some cities. Notice we do not ignore any of the major geographic regions because these are strata. So we never ignore a stratum. We always consider all of our strata, but we do ignore clusters. So we are going to ignore some cities and towns. We of course randomly select using a random number generator which clusters we're going to visit. And you might actually take it another step further and partition each cluster into strata based on age. So in this example here, what I'm doing is dividing the US into 1, 2, 3, 4, 5 different strata. And then within each strata, I'm identifying clusters like cities and towns. And then I'm saying, well, forget some of these cities. I'm only going to sample a randomly selected subset of the cities from each cluster. Or sorry, I think I misspoke. I'm only going to sample a randomly selected subset of cities from each geographic region. So a random set of the clusters, but from each stratum. And then within each city, you might also use strata to divide up each cluster. And so that could even further help you. Maybe you want to make sure that you get respondents from each age group in each of the cities that you visit. And then you do a simple random sampling based on that if you have a frame. Just another alternate example. If you want to, again, same idea, find out what proportion of Americans are in favor of legalizing marijuana, but you don't have the budget to do a simple random sample of all Americans, right? And you don't have the budget to do a stratified random sample of all Americans, we can use multi-stage sampling basically to maybe partition the US into strata based on city size, because I think there's evidence that shows people who live in larger cities tend to be more progressive, maybe more in favor of legalizing marijuana. And then within each size stratum, so you've got like basically a stratum with large cities, medium cities, and small cities, small towns. Within each stratum, you might partition into clusters, which are like cities and towns that belong to those strata. And then you're going to randomly select which clusters to visit, but making sure that you choose a proportionate amount of cities in each stratum. And then you want to maybe partition each city based on political party to make sure that, again, you get opinions equally represented or proportionately represented anyways from conservatives and progressives and so on. And then of course in the end you either have to do simple random sampling or systemic sampling for each of your smallest unit, right? So for each of your strata within cluster within strata.